So next up here, we're looking at the ideal gas law. PV equals nRT, and then N times R is approximately 8.31. R is your gas constant here. And we are going to approximate the change in volume if the pressure changes from 2 to 2.2 kilopascal, and then temperature changes from 350 degrees to 345. So first of all here, your pressure is going from 2 to 2.2. So that's going to tell us that dP, or delta P, is going to be end minus start, 2.2 minus 2.2. And then for temperature, we are going from 350 to 345. So that means that dT, or delta T, is going to be end minus start, 345 minus 350, which is equal to -5. Okay, and then our delta V, we're approximating that, is going to be approximately equal to dV, which is the differential of V. So we first need to solve this equation for V. So we've got PV equals 8.31 T. And then we can divide both sides by P. So V is 8.31 T over P. Or if you want, V is going to be 8.31 T times P to the -1 power. So that's our function V. So then the differential of V is going to be dV dP times dP plus dV dt times dt. So that's definition of differential. If we go back up here, our differential right here, x derivative times dx, y derivative times dy. So our variables are p and t instead of x and y. And then we also wrote that in the partial notation here. So that's what we're doing. So notice it looks like the x's would cancel, it looks like the y's would cancel. And that's happening down here too. So partial with respect to p, so p is the variable, t is a constant. So this -1 will come down times what is in front. So -8.31 times t, and then decrease your exponent by 1. So p to the -2. And then times dP plus t derivative here. So t is the variable, 8.31 p to the -1 is a number. So we've got a number times t, differentiate that, you're going to get the number 8.31 p to the -1. And then times dt, change in temperature. So now we'll go ahead and plug in our values here. So -8.31. And then the partial here, you're going to evaluate at 2 and 350. Since those are our initial values, this is going to be the P0, and the 350 is going to be T0, initial temp. So this is T, P to the -2, so the temperature is at 350. And then P to the -2 is P squared on the bottom. So that pressure was 2, and it gets squared in the denominator. And then times dP, and dP is right here, 0.2. And then plus 8.31 times P to the -1. So divide by P, which is our 2, and then times dt, and change in temperature was -5. And then if you plug this into the calculator, you will get about negative 166.2. So that is telling us here that our change in volume, our volume is going to decrease by 166.2 if our pressure increases and our temperature decreases. So both those things should make the volume decrease, because you increase pressure, volume's going to go down. And then if you decrease temperature, there's less kinetic energy in the molecules. They get closer together, volume goes down.